Science is a cumulative and endless series of empirical observations which result in the formation of concepts and theories, with both concepts and theories being subject to modification in the light of further empirical observations. So, science is both a body of knowledge and the process of acquiring and refining knowledge. So this is what Fitzpatrick has said about the science. So in this context, in this module number 9, we will continue the different process skills which are very essential in doing the science. And besides that, a little bit of highlights on the different thinking skills which are very essential in learning or doing the science. So that will be dealt. And today's module is module 9. And according to Dr. D.S. Kothari, to learn science is to do science, and there is no other way of learning science. So science cannot be learned by cramming or by mugging up. No, it has to be done. So science, and it has to be done in a very, very systematic way. And there is a systematic process of learning the science. So this part in this lesson, module number 9, we are going to tell. In the previous module number 8, the different basic process skills of doing science, it has been dealt. And today a little bit of reflection on these integrated skills or advanced process skills also is mainly highlighted. So in this figure you can see that integrated skills, which are also known as advanced skills. So in the module number 8, the different basic process skills which we have already dealt. So all those basic process skills are the prerequisite for these advanced skills. And this here you can see a series of the skills here. Number 1 is identifying and controlling variables. So here identifying the main problem, which problem related with the learning of the science. It's a problem based on any phenomenon, scientific phenomenon or natural phenomenon or the event. And it's associated other factors. So that problem is to be identified along with its different factors. So that is also a special skill is required. Their reading skills, thinking skills, etc. are also required. But identifying and controlling variables itself is also one of the skill. Then second one is defining operationally. So once that problem is identified, located, and it is to be stated in a simple sentence scientifically, so that all the factors, all the variables which have been considered for the purpose of doing research or the study or investigation, those things are to be defined very clearly, distinctly. Then after that, the students or the learners can collect more informations also, and they can they make the different hypotheses or possible or nearest answers to that particular problem which is identified and which is defined operationally. So for that there may be construction of the hypothesis or formulation of different possible answers to that problem. and that is the third steps. And when all this probable experimentation, all these three skills have been processed, so after that it will be followed by the another activity that is called the experimentation. And in experimentations, those hypotheses which were formulated as a guess or as a possible answers on that particular problem, scientific problem, it has to be tested. So the testing of hypothesis, that process is also known as the experimentation or experimenting. And once that experimentation is being done, and all those informations or the data of that experimentation, these are to be arranged in the form of a table, like making the tabular representation of all the data which is being observed during experimentation. And those tables can be grouped together also. Group in the sense depending upon the need, the tables can be grouped. So table number 1, table number 2, table number 3, like that. And besides table, some of the investigators, they like to give the graphical representation also. They will show that particular information which was procured during the experimentation. It can be arranged and displayed in the form of graph also, or mostly in the table, and some investigator would like to present it in the form of graph also. Then once that table is ready or that grouping is being done, so then another skill, number 6th skill is required, and that 6th skill is the interpretation of the data. That what is being mentioned in that particular table, it is to be interpreted in a scientifically a simple language. So that is called interpretation of the data or interpretation of the informations. Then once that interpretation is being done, that acquired knowledge or that acquired conclusions, that can be further taken for the further investigations or further research work, or further validation can be done. So this is a continuous process. Once the validation is being done, then again that problem, another problem related to that previous problem can be identified and again defined operationally. Then for hypothesis formulation will be there, then that can be done with experimentation, then followed by tabulation or grouping or graphing, then the interpreting, then again investigation. So this way, all these 7 types of skill are usually included in the scientific invention, scientific process. So this way the cycle goes on, and this is one of the way of finding the scientific knowledge. And now this scientific different method which we have discussed, they were 7 in number, and these are also known as the integrated process skills. And here mostly higher order thinking is involved, such as they have to do the logical thinking, critical thinking, creative thinking. So that type of thinking will be enhanced among the learners. So for this integrated skills, We cannot expect that the learners in the schools, they will master, they will excel all these skills of making hypotheses and doing experimentations, tabulations, graphing and interpretations, then again further investigations like that. Depending upon their intellectual capabilities, a teacher can organize, or a teacher can provide that opportunities to make the use of this type of integrated or advanced type of skills among the learners. And in such cases, we cannot expect that our students or the learners will do excellently by making the use of these integrated skills. They can come out with the best solutions of the scientific problem. So in such cases it may not happen so. So for that, a teacher always need to be patient. Patiently, the chances or the opportunities are to be provided to the students. And this is one of the way to make the learners to learn that how science is being done, how the science adds a new knowledge in its respective field. So for that, this scientific method or the it's a combinations of all the integrated process skills is very essential in the learning the science. But at the same time, we must not forget about not we but as a teacher, science teacher, it is very essential to place in such a positions from where a teacher can really play his or her role in a very significant manner. So certain few things while doing the science in the classrooms or in the schools, or while performing the teaching learning activities, that time a science teacher should be able to do these 10 things which is being displayed in this figure. First one is the science teacher must enable the learners to train them for use of senses to carry out focused and objective observation in science. So this is one of the basic skills, that how to make the observations which we have already learned, and that observation is to be done in a focused manner, focused with full concentration and unbiased way, objective way, by making the use of different senses which we have already dealt in module number 8. So this way the science teacher has to train the learner. And secondly, science teacher also has to help the learner to learn to record their observation in both qualitative and quantitative manner. How to make their observation in a qualitative data and the quantitative data. So both way the learners should be able to record their observations. So this type of opportunity is to be provided by the science teacher. Science teacher must enable learners to use measuring instrument precisely. Different measuring instrument that we have already dealt in the module 8. Different instruments like how to handle microscope, how to handle the common balance, how to handle the spring balance, how to handle the measuring cylinders, and so on. So science teachers must enable the learners to make the correct use of the different devices which for the measurement, and they also should be able to make the use of appropriate units to present their data or the observations. Like somebody's height is 5 feet 4 inch, so but now in centimeter how much it is, so that type of unit they should be able to use it, and how this can be converted into each other, like 5 feet 4 inches can be converted into centimeter. So those type of things also are to be taught to the learner. And fourthly, the science teacher must encourage the learners for communicating their observations honestly without hesitation and feeling no fear while reporting. So that means the whatever observation they have made, and whatever after measurement, whatever findings they have found, so these are to be communicated with the other people. So for that purpose, we must encourage, or the science teacher must encourage the learners for communicating their observation honestly and without hesitation. With lots of self-confidence are to be developed. And when they present their report, so that time they feel no fear. So this is a very important duty or the role of the science teacher. Fifthly, the science teacher must be able to make the use of appropriate questions to guide learners for making authentic observations and inferences. So a science teacher must keep certain critical seeking further information type of questions ready with him or her, so that questions will guide the learners for making their authentic observation and inferences. So they should not go haywire while making their observation. So it has to be a very clear cut, and their information also has to be very authentic. So for that, some questions, a science teacher, critical questions are to be kept ready, or to interact with the students. Sixthly, a science teacher must be able to help learners to classify various objects or events and developed ability to explain the underlying criteria. So this is a classification skill of classifying. They should be able to classify the various objects, they should be able to classify the various types of events, and those along with that, they should be able to develop the ability to explain the underlying criteria of all those classifications, on what basis the classification is being done. So that has to be made clear to the learners by the science teacher, or the learners must be able to do so. Then seventhly, the science teacher must be able to provide opportunities to use different means of communication, communicating data or their findings or the results of their investigations, such as charts, graphs, models, etc. So the students can communicate their findings of their experimentation or the investigations not only in the written form, but they can show it in the form of a chart, they can make the graph, they can make the models. So that type of opportunities are to be provided by the science teacher. And science teacher, eighthly, must be able to motivate the learners to share their observation and inferences with each other. That is a part of communications. So that they make the graph, models, they make the different tables, diagrams, charts also, and they should be able to share that one with their friends. So this is for the developing the communication skill. And next is, science teacher must be able to encourage the learner to predict an event and then test it if it is coming out to be true or not. So this is for the development of the skill of prediction, making prediction. So in science, one of the skills prediction is required. So the learner in the schools, they should, while learning the science, they must be able to make some predictions of the event, and whether that prediction will come out true or not, that is to be experimented, that is to be tested. So that comes in the integrated skill also. And lastly, the 10th way, the science teacher must be able to create ample opportunities for learners to use science process skills and integrating them wherever is the scope. So lots of opportunities are to be created by the science teacher for the learners, so that the learners, they make the use of different science process skills, like basic one and this integrated one also. Basic one, observing skill, classifying, inferring, communicating, predicting, like that. And in integrating, making hypotheses, doing experimentations, drawing the conclusions. So all these things the learner must be able to imbibe. So these are the basic roles of a science teacher, so that all the learners in the class, they will be able to develop these both basic process skills as well as the integrated skills. And besides this learning of the science and inculcating the different type of process skills among the learner, the science teacher must make the arrangement in the class in such a way so that it will enhance their way of thinking also, enhance the way of quality thinking. Reasonably they can think with logical thinking, and plus they can think critically about the different evidence also. So this is one of the scientists, famous scientist Carl Sagan. He has opined that science is more than a body of knowledge, it is a way of thinking. So in the science, not only the different process skills will be developed among the learner, but also the way of thinking also will get enhanced. So especially the logical thinking and critical thinking. So in logical thinking, it is the it's a reasoning before arriving at any conclusion. The students, they should think logically before they come to one conclusion or generalization. They must have enough reasons why they are coming to that conclusions, and they have to reason out their observations. So in the science, they will do lots of experimentations also. In that experimentation, the observation skill is required, and that observation should produce a chances for the learner to think reasonably, or to reason out their observations. And they can look for the certain patterns in terms of their cause and effect. So what is the cause of that particular event, and what are the effects? So that type of cause and effect relationship the students will learn, and finally they come to the conclusion. So that type of thinking is called the logical thinking. And besides that, the learners, they must develop their critical thinking also. And this is critical thinking. It is an ability to analyze one's experiences and review your own actions through reflecting on them. So in the school, while doing science, or while teacher is teaching the science or learning is taking place among the learner. So that time the students, they are gaining some experiences, and those experiences and their own actions, again it can be reflected by the learners. Means based on their experiences they got so and so the result, that was the finding, and that time they further reflect on it. So actually this critical thinking is a abstract thinking of reflecting on our own actions. Sometimes like suppose you are having that problem of network, so network is not there and immediately you say that, oh, I will not attend this class because the network is not there. No, there again reflect it. Maybe the network is going on and off. Now again it must have restored, so let me give a try. So that type of thinking, here it is a critical thinking. You are getting some experiences, and based on that experiences again you are reviewing your actions. You want to change their actions, not to give up but again retry. So that type of critical thinking is to be enhanced, or it has to be nurtured by the science teacher in the school while doing the science. And sometimes like while doing the experimentations, they come across with some mistakes. They will do some mistakes, or sometimes they will not get the result which they were supposed to get, expected result. So that time we can encourage the students by asking good questions, so that they can rethink or redo that experimentations without any hesitations, and with much more focus they can do that experimentation once again. So instead of giving it off, so the experimentation should continue. And for this purpose the teacher can keep some open-ended questions to encourage the learners, and analyze the information and let them think critically the various aspects of a given problem or the experiences. So these two types of thinkings, besides that creative thinking, so these two thinkings will be also developed while doing the science. So this thinking is also one of the skill which will be enhanced while learning the science. So in this figure you can see, actually this you have already drawn in the semester 2, the what is scientific tempers and what are the characteristic features of the individual having the scientific temper. So here it is being given like while learning the science, slowly the students they will develop their scientific temper. So they start thinking logically, they think critically, they'll respect for that evidence of their own proof of their own findings. They become objective, unbiased, open-mindedness, honesty in reporting, skepticism, perseverance, these type of values, these types of attributes will be imbibed among the learners. So for that purpose, these different process skills, basic as well as the advanced, are very essential. And usually there is a tendency that science is to be learned by scientific method only. So this science can be developed, science can be learned through scientific method only. So sometimes if you be very restricted to this statement only, that yes, science is to be done by scientifically, so such cases may not may not be a satisfactory answers for the learners also, because in the history of science we can see there are so many scientists, they haven't followed that process of making the identifying the problem and defining that problem, then making hypothesis and doing experimentation and observation and finally coming out to that result. So there are some cases that science teacher can share in the class while learning the science about that. The science cannot be learned always by the scientific method, but there are some incidental discovery by the some scientist. So how they have discovered certain very unique findings. For example, here you can see the a photo of the famous biologist from Scotland, Alexander Fleming. So uh, Alexander Fleming, he is working in this lab here in this photo, and that time when Alexander Fleming was working with a kind of the one kind of a bacteria that is called the Staphylococci. So he was doing some investigation on it. Then he stopped that experimentation and went for holiday. Then after holiday, he returned back and he found that one of the petri dish, he left it open. He forgot to cover it. So one petri dish was left open on his lab, and that time when he returned back, that time he found that blue-green algae mold or kind of a fungus has already developed in that petri dish. And then he made the keen observation and he found that blue-green fungus had already killed off all that Staphylococci bacteria. This Staphylococci bacteria, it was already killed. And no Staphylococci were there, but only that blue-green mold or blue-green fungus was there. So he found that mold or that fungus contained a very powerful antibiotic. Name of that antibiotic is the penicillin, and that penicillin could kill all these bacteria, that is Staphylococci. Staphylococci was very harmful bacteria. It used to cause the diseases. So it used to have a toxic effect on the human body. So now once the penicillin, that fungus was developed, all the Staphylococci died. So that we found, oh, this is a very good antidote of that Staphylococci bacteria. And if there is any skin infection with this bacteria, Staphylococci and all, if you apply that penicillin, another kind of fungus, so that penicillin will inhibit the growth of that harmful bacteria. So now also it is very useful. And see this in his this discovery, there is no systematic way of doing the making hypotheses and doing experimentation, etc. They were not there. So it happened all of a sudden, accidental discovery. And so science, sometimes it happens accidentally also. Another example, law of gravitation. Here, law of gravitation you have already learned. Our Isaac Newton, how he propounded the laws of gravitations. You can see here in this picture itself also. He's sitting under the apple tree, and suddenly apple tree falls on the ground. So that incident he mentioned to one of the archaeologists who has written a biography on Isaac Newton, and that name of that biography, the title is The Memoirs of Sir Isaac Newton's Life. and the author is William Stokely, and it was published in 1752. That time, the Newton had shared his story, Apple story, to the author William Stokely, and he has relayed that matter in this way. So after dinner, the weather being warm, Newton is narrating here. After dinner, the weather was being warm. We went into the garden and drank tea under the shade of some apple trees. He told me, that means Newton. You are just in the same situation as when formerly the notion of gravitation came into his mind when apple fell down. So that notion about the gravitation came into his mind, Newton's mind, and it was occasioned by the fall of an apple, and as he sat in contemplative mood, contemplation. Why should that apple always descend perpendicularly to the ground? Thought, he gave that thought to himself. So that time he found the answer. Newton found the answer. It must be due to the law of gravitations. And another accidental discovery of the science where they did not make any hypothesis. So that is the phenomenon of the radioactivity. In this picture you can see one of the famous scientists from France, French scientist Henri Becquerel. This is the picture of Henri Becquerel, and he was working in some phosphorescent material. It's made up of phosphorus maybe, and which used to ignite, phosphorescent material, which used to glow in the dark after the exposure to light. So that chance of discovery came in one day it came during an experiment involving uranium enriched crystal. He believed that sunlight was the reason that the crystal would burn its image on a photographic plate. Then he used to do his experiment with that phosphorescent material, usually the uranium enriched crystal, and that experimentation he used to do during the nice sunlight. Then one day what happened? That day the sun was not bright enough, so that day was the stormy day. Most probably the cloud was there in the sky in the year 1896, and he decided, this means Henri Becquerel decided to leave it. Oh, today the weather is like this, so I'll leave it. I'll not do that experiment that way. So he thought, I'll resume his experiment when the weather becomes better. So then a few days later he took that particular crystal, uranium enriched crystal, out of a darkened drawer, and for his surprise the image burned on that plate was already, it had become fogged. That means the crystal had still emitted rays, though there was no sunshine. That crystal was kept inside the drawer, and after 3-4 days they took it out, and there still he found that the crystal was emitting the rays, and the drawer, inside the drawer there was a lack of sunlight. So it was a surprise for him. So it was clear that there was a form of invisible radiation that could pass through the paper, causing the plate to react as if exposed to light. So that time he realized, so for the radiations that sunlight is not required. So even in the absence of the sunlight, invisible radiation can take place, and that uranium enriched crystal still can emit the light. So that was his one of the findings, and these findings further investigated and continued by the famous two scientists, Perry and the Marie Curie, husband and wife. They were the scientists, and they studied that particular phenomenon of radioactivity very nicely. But that incident happened during Henry Becquerel's observation, and most probably they must have done that experimentation, making hypothesis and experimentation by Perry and Curie, Madame Curie. So they became famous for that radioactive phenomenon, but actually the radioactive phenomenon was observed by Henry Becquerel. And nowadays everybody is familiar with that one of the device, that is microwave. In microwave we can roast the popcorn. So how this discovery of microwave took place, and here you can see the scientist. His name is Percy Spencer. He is holding one microwave machine, and here it is shown that some popcorns. So he has done the experiment. He was a Percy Spencer. He is an American engineer. He is an American engineer working for one company, Raytheon, in 1945. And that time he was working on one substance that is called magnetron. And that magnetron was capable of beaming high waves of radiation. He found that magnetron is that substance, and it can give out the high waves of radiation. Then he noticed that while doing maybe that his work on magnetron, so that time he has kept one chocolate bar in his pocket. Then he just felt his pocket. He found that that chocolate is melted. So then he became very curious why this chocolate bar got melted. Then in that magnetron, where the high voltage, high waves of radiation is going on, so there he placed a bowl, and that bowl was full with the popcorn. And slowly what he observed that popcorn started to pop. Just like in the during winter we roast this popcorn in that sieve container. Similarly, that in that magnetron, there he found that popcorn started to pop. Then Spencer, he created, that idea was enough for him. Then he created a high density electromagnetic field by feeding microwave power from magnetron into metal box. And in that metal box, that popcorn, they were not able to escape out, or that particular voltage, high density electromagnetic field, they could not come out. So when the food was placed inside that box, the temperature of that inside that box was increased very quickly, and that was in the month of the October. And it worked. That food was placed in the box and food was prepared, cooked in no time. So that company, Raytheon, that after 2 years in 1947, they patented the technology, and it became available in the public in 1947 onwards. That microwave is there. Now I think more or less every house is, they are keeping this microwave device for cooking the food in short interval of the time, short span of the time. So these are the here in this example you can see that science can be learned by making the use of different process skills, basic skills as well as the advanced skills also. But side by side, then there is a chances that science, any discovery can happen not in a linear process. but it can be with the simple observation. For example, for Isaac Newton, it was a simple observation. Why that apple fall down on the ground perpendicularly? So that observation became very keen observation, critical observation. Then the law of gravitation was propounded. And similarly, in this radioactivity, when Becquerel he was doing the experimentation, when he's studying about that radioactive uranium enriched crystal, so that time he made a systematic inquiry. First in the light, then accidentally when stormy day there was no light, then after 3-4 days he took it out. In the absence of light was also that was emitting the light, that crystal. So that he did that inquiry systematically like that. And similarly other this Percy Spencer's experimentation and penicillin's discovery of penicillin. So all these things, they did not follow the scientific method, or they did not follow that integrated process skills of doing science. So it happened all of a sudden. All of a sudden means a kind of a accidental discovery. So however, all this invention which has already occurred, whatever we have mentioned just now, so this experimentation, their experimentation, though they found the result accidentally, but this experimentation now also it can be tested, it can be validated, or it can be again the new theory can be established by making the use of all the process skills, both basic as well as the integrated one. So these things are to be made very, very clear to the learner, and as a teacher of science, one should provide them the opportunity to discover the science and in their surrounding by using the process of inquiry. So process of inquiry is very, very important. It is also one of the skill it has to be developed among the learners. So in this lessons, more or less you come to know about that how the science is being done, how the science is being learned, and what type of different skills in the form of integrated skills can be very essential while doing the science, and plus what is the role of the teacher or science teacher. Here you can see the role of the science teacher. So this role we have to be sure what we are supposed to do. So this thing we must be very, very clear. We means you all have to be very clear about it. And we know there are 10 ways the teacher can make the ground or make the clarity and plus opportunities for the learners to learn the different type of skills, to make the use of different types of process skills. So for that, the role of the science teacher is very, very particular, very, very essential. And without the help of the teacher, the learners cannot imbibe all those process skills, both basic skills as well as the integrated skills. So in these integrated skills, all the basic skills are incorporated. These are the prerequisites. So these are the gist of this particular module. So these things like how to make the use of the integrated skills, identifying and controlling variables, defining the problems, for making hypotheses, doing experimentation and making tables or tabulations, or making the graph or grouping, then interpreting the data and further investigations. This is a scientific method, and in the unit 2, the different methods, different ways of doing the science, and one of them it is mentioned as inductive method, inductive deductive method. So there, all these integrated skills are utilized, and doing many other research work, a higher level of research work, these integrated skills are being utilized. So this we must give a try. Not only try, actually we must make our students able to make the use of basic process skills first, then that will help them to develop their integrated or advanced skills. So with this, the today's lesson is ended up, and this is how we are supposed to make the opportunities or develop the opportunities among the learners in the school educations for the systematic process of learning science. So that's why we can fulfill the opinion given by Dr. D.S. Kothari: to learn science is to do science, and there is no other way of learning the science. Hope this lesson is clear to you, and you must relate this module number 8 and module number 9 for these different process skills in science, whatever science, biology, physics or chemistry. So with this, the class is ended up. Thank you.